don't trust a paper or analysis, trust the consensus of a literature. Okay. Right? Because in that sense, you have a better chance that your results will generalize.
Welcome to another session of Business Data Science with Delali, and today is a special edition because I'm here again with my friend Dr. Augustine, who is a professor of economics, currently working at Davidson College. In fact, I always make the joke that he's an Ivy League guy because he did a postdoc in Harvard as well. So I'm very glad to have him here. But here's the special thing. Augustine and I co-founded the Ghana Data Science Summit, and so we are here today in Ghana at Ashesi University, which is one of the private international universities in Africa. And I want to take the chance to, have him, share his opinion on a question that I see around as we go about teaching people data science here in Ghana. So here's my question, Augustine. The question is, it's been known that if you do some experiment or if you run a study and you have your conclusion, sometimes if people replicate the same study, they don't get the same conclusion. In fact, as a matter of fact, I read somewhere that about 36% of the studies can be replicated and have similar conclusions, but a vast majority of that, more than 60%, usually end up not having the same conclusion, right? And so in practice, we run experimentations when we are launching products, when we are testing the effectiveness of marketing campaigns, and we have many different options to take. But we run experiments, we end up taking the ones that has a particular conclusion that we want. And so we tell our stakeholders that, okay, when we run these campaigns, these are the outcomes or the responses that we'll get based on those experiment results. But what that tells me is that sometimes some of those experiment outcomes may differ, right? I have two questions around that. Number one, why do those happen? Why is it that sometimes when we replicate some of those experiments, we don't get the same result? That's number one. And then number two, how should we as data scientists, how should we communicate those results to our stakeholders? Or what should we be aware of when dealing with situations like this?
Delali, once again, thank you for having me on Business Data Science with Delali. And of course, Ashesi University has been wonderful and they've been one amazing host for our conference. This is an important question that you've raised. So I think I'll tackle it in a couple of ways. First is to remind all of us that the beauty of statistics is that when we want to learn about a population, say I want to learn about some outcome in the population, say Ghana, although we may not have access to everyone in the population, we can draw a sample which is a subset of that population and be able to perform inference using that sample. So of course, there are some key things we need that sample to possess. We want the sample to be representative of the population. Now, oftentimes when you run an experiment, you must select the sample on which you perform the experiment. And one key reason why, some experimental results may not replicate when you go to other target populations is the representativeness of the sample, right? Yeah. That's a key thing. So, of course, if your sample is more representative, you have a better chance that the results can be replicated. Yep. So, in terms of thinking about experiments, one of the important things to consider is your inclusion and exclusion criteria. Who is in the sample and who is not going to be in the sample. And in particular, those on which you would implement or roll out the campaign that you are testing, are the demographics of those group of people going to be similar to those on which the experiment was run? And this is a key issue that arises a lot in drug trials, for example. Yeah. The FDA does lots of drug trials in the United States, and often there's some inclusion and exclusion criteria for which people are admitted into the trial. Now, of course, based on the outcomes of the trial, a drug is going to be recommended for mass production or not. Now, of course, we all know that, sometimes the effectiveness of the drugs can vary in the actual population. Yes. That's no surprise because it is related to the inclusion and exclusion criteria of who was in the experiment, right? So that's one reason how representative your sample could be. The other thing that I think people should remember is that this is why it's so important not to base a lot of important policy decisions on just one experiment. Yeah. I like to think that empirical results or results that we may want to use for policy are all, you can think of them as all part of a pie. if you take a big pie, for example, each experiment I like to think as contributing just a slice to that pie. Right? So sometimes when you think of the pie as the whole, that experiment is only one piece of the pie. So often I like to have more validity in a set of results if it has been tried and replicated in multiple contexts,
places,
right?
multiple
So that's
contexts,
yes, so that's really crucial. So I always tell students, in particular anybody who wants to rely on analysis, that don't trust a paper or analysis, trust the consensus of a literature.
Okay.
Right? Because
Okay.
in that sense, you have a better chance that your results will generalize.
Yeah.
Right? So that's one key thing. Like, people are often so quick to want to depend or use only one outcome of an experiment to make really important decisions. So if you have a very high stake decision, it may be worth your while to attempt a couple experiments in different contexts before taking action. Of course, if your time permits you to do so.
Yeah. You know, in particular, one thing that relates to this is sometimes publishers or, you know, researchers are forced to publish results that have a particular conclusion.
Yes.
You know, have, you know, a p-value less than some threshold that we say it is statistically significant. Meanwhile, maybe they have done this like 20 times and only one of that actually showed the p-value that they want. And then they publish that. And so, you know, when we take these papers, we read them, we want to implement them, we are likely to, you know, to end up having some of the 19 results that they have that didn't have a p-value, a particular, you know, p-value that they were looking for.
Yes.
How do students, you know, interpret papers like that, given that most of these, you know, editors and reviewers want you to publish, you know, the conclusion that, you know, we desire. So this is one of the things that I see some of the students actually asking about, and I think that, you know, your perspective on this, you know, can be very helpful to that.
Right. Well, one of the first things I encourage students to do is, if you've seen a new paper that has a surprising result, you should be a little bit
suspicious,
skeptical. You know,
skeptical.
Maybe not suspicious, but skeptical is the word. Maybe a healthy skepticism, right? Because if you think about it, surprising findings don't come too often. That otherwise, if they are too often, they are no longer surprising.
Yeah.
So anytime you encounter a surprising finding, you have to ask yourself, can I go back to the original paper? Can I read their introduction? Can I read their method section? Is their data available? Have they made their data public? Is their code available? Right? These are sort of questions you ask. And if you have time, probe them further. And if you have time, even investigate further. Now, of course, you can't go about investigating every analysis in detail. We don't have time. But if the question or the paper is in your area of interest, which relates to your research, maybe say in a dissertation or so, then it behoves on you to take your time to interrogate the results, right?
Yeah.
So I think that we as consumers have to be more skeptical of results.
Yeah.
We should be pushing for standards to change in the profession, where people are more willing to share their code, are more willing to share their data. And a related point to that is that we should be welcoming to all types of results. And so this relates to a bigger thing in the profession, where we should be more welcoming to all types of results. Because if we are more welcoming to all types of results, then people will be incentivized to publish or write about any result they find.
Yes.
And in the same breath, we also should be a little bit more kind to people whose findings may later on be shown not to be very accurate. Right? Because mistakes and errors happen. So if we are going to have a culture where we have an exchange of ideas, then of course the profession should also be such that we should not over-penalize researchers who, for one fault or another, ended up in a situation where some of their results may not be replicated. We should show kindness to those researchers, especially if they are willing to admit it and come to submit corrections. But oftentimes, the reason researchers sometimes shy away from sharing all of this information is that some people come at the issue of replication as though they want to antagonize the researcher, as though the researcher, by definition, intended to mislead people and intended to produce incorrect results. So sometimes we all should, you know, share in this process of being more open, being more accepting, and trust one another a little bit more. Right? That we as researchers are all committed to the same cause. And in that case, I know this, you know, this is nice to say, but it's also very difficult to do in practice. But of course, we can start from somewhere. So the journals in particular have to be better at encouraging replications, they have to be better at encouraging researchers to submit corrections, and they have to be better at not antagonizing researchers. So there's a number of things that we can do that to change the culture around replications.
This is very helpful. Thank you very much, Augustine. And for you listeners, Look, I have done a lot of videos on experimentation. Definitely feel free to watch them. But you know, be very skeptical of experimental conclusions, or you know, results from experiments. And again, this relates to the first thing that we said. Curiosity is very key in any investigation and in any data work. And so I hope this is very helpful, and see you in our next session. Bye bye.